Young people, welcome back. B&B in the house. Mr. Kraft, the bearded math brother, here to help you with your algebra needs. And geometry, algebra 2, we cover a lot of stuff. But what are we covering today? Looks like chapter 4, lesson 5. The learning objective stated by the textbook. Investigate relationships between quantities by using points on scatter plots. Second objective, use lines of fit to make and evaluate predictions. Okay. Guys, let's get this party started. I'm going to admit or say straight up, guys, one of my more, what we're doing, what we got going, right? So not a lot of math in this one, guys. I'll be the first to admit, just the objective itself was kind of clear to me that it's going to be a different type of lesson today. So let's get this handout out of there. Let's see what we got. Let's start with, do you know what scatter plot is? All right. So let's get a quick pause in because a lot of vocabulary today. Scatter plot, guys. It's a graph. It's got a bunch of dots on it. And those dots represent information. They're scattered, plotted, and scattered across the graph, and it tells you things. Lines of fit, kind of same thing. You can see a line, it tells you it fits within the data. So there'll be a lot of just talking about what we see in the graph, what it's saying. Might use some funny examples, or maybe they're not going to be funny. But let's get this going. But again, you guys have done graphing. You've seen graphs, interpreting information, and there's a few major things that they're going to ask or talk about, and let's see what they are, and let's get this going. So I'll say them now. Positive correlation. Positive, going up, the correlation. It's like money and a job. Positive correlation. The more hours I work, the more money I make. The longer I'm at that job, the more I get, right? Negative correlation. The less I eat, the less I weigh. Some correlations, you'll see. Positive up, negative down. No correlation, you can't tell me anything because the information you're looking at doesn't help you determine anything. It's all over the place. How's a person never eat and get fat? Doesn't make sense, all right? How you at your job all that time, you ain't got no money? Don't make sense, right? There's no that does not make there's no correlation. So you'll see. Let's have fun. Here we go. All right, so what I see, what I got, and what's going on this big old thing is a whole lot of, there we go. I'm like, why does it look like that? Probably because I wanted to size it so right. So, sized up in there, guys, and the directions are clearly stating, determine whether each graph shows a positive correlation, a negative correlation, or no correlation. If there is a positive or negative correlation, describe its meaning in the situation. So situations, right? Every single one of these graphs is a situation. There's going to be a positive correlation, a negative correlation, or no correlation. So describe its meaning. If you don't do that, you didn't do it right, you can't just write positive correlation and expect to get credit. Or depending on your teacher, maybe you will. So first one, number one, looks like calories burned during exercise. Well, I recognize that there's a positive correlation because it looks like those little dots are going upward. Started down there at 0, ended up all the way up there at 500, right? It's going up, positive correlation. And you can tell the time spent, whether it was 30 minutes, 40 minutes, or 50 minutes, the more time spent, the more calories you burn, right? These means, did I really say these means? That's why I teach math, y'all. These means the more time spent exercising, the more calories we burn, right? That's what your PE teacher been telling you since? Just kidding, right? All right, so that's number one, and I did both stated the correlation and what that meant. How about the next one, number two? Number two says library finds. So my y-axis is dollars, fines, right? My x-axis, books for all. So So I'm saying no correlation because they're all over the place. It's not looking like it's flowing. It's not looking like it's flowing upward. It's not looking like it's flowing downward. It's just points all over the place. So there's no correlation there. And think about it. That does make sense that whether you borrow one book or you borrow 10 books, that doesn't directly relate to how much you'd be fined, right? You might take one book back, but you kept the other 9. Of course it's gonna be expensive. Or you took all 9 books back, but you couldn't find one. So it all just depends, right? There's no direct correlation between the amount of books borrowed and the fines. Makes sense to me. Let's move on. Next. All right, so what are we looking at here? It looks like I got a negative correlation. And the reason why it's negative is and this is what I mean by you start at the left of the graph, and then what happens as it goes to the right. It looks like it's going down, right? Because again, in this graph, you can see 0 is to the left. So 0 pounds, no repetition, 20, 40, 60. So of course, the less you got on there, you ain't gonna lift nothing. But the minute you put some weight on there, you can lift a lot. The more weight you put on, the less you can lift. So the correlation is a negative correlation. It's going downward as it increases, right? And the heavier the weight, the less the repetition. That's what's happening in this situation. That's what's happening in this situation. So we've had 3 situations. The first one was a positive correlation, whereas the more time you spend exercising, the more calories you burn. In the second situation, and the third one, the more weight, the less you can do. Now, for the last one, I'm going to put a slight positive correlation. Would you agree? You see those outliers though? The ones that are kind of off to the side, they're like, hold up, that kind of makes it look like it's not. But if you look very closely at it, it goes from 99 to 2000 to 2001. So it seems like every single year it's going up though, right? It's only like 1 year where it went up, then it went down, or maybe 2 years, right? So I'm going to say revenue increased almost every year because I can see those 1 or 2 little points right there, right? Boom, then it drops, right? But then it goes back up, and it goes up. So it's a positive correlation. It's going up. But then again, there's one more drop. So overall, I would say it's a positive correlation, but that's why I use that word outline there. There's 1 or 2 that kind of pull me away from where it fits. Fits upward, right? And as I say that, scatter plots and lines of fit looks like baseball. You play a little baseball? So the scatter plot shows the average price of a Major League Baseball ticket from 97 to 2006. Hey, my son was born in 2006. That was the best year of my life. Okay, I'll just leave it. That was the all. Seeing the moms go, oh. But anyway, determine what relationship, if any, exists in the data. Explain. Well, positive correlation, guys. And you would agree because you see it's going up. It increases, right? It wants me to explain, but you explain. Me saying what? Because. Why would you say it's a positive correlation? Well, between, because, I don't know what I'm going to put. Well, I guess I could say something like between the year of, and where? 2000, no, I can start at 97. Let's put something there that's going to make sense. The price increases. And I see it's BW, I think it's supposed to say BC because year and average price increase. Yeah, I'm showing there it is. You know, starts off at 97, it's what $12 or something? And then by the 2005, it's already up to $22. That's increasing every year. That's a steady increase. What about B there? Use the points 1997, 13. Bam, that's the red. And the point 2005, 22 to write the slope-intercept form. What? Yeah, guys, it ain't going nowhere. See, I was bringing it all together. We didn't have any idea of those M's and those X's and all of that nonsense, but y equals mx plus b. We can use real data, right? Back in 2006, Well, heck, way back in 1997, right? So we're gonna find the slope by doing what we already did. We got a y1 and a y, I'm sorry, we got x1 and a y1 and an x2 and a y2. So y2, 13 minus 22. Or 22 minus 13. Remember, you can swap those as long as you keep them in order. I've been trying to keep things in order in these videos, but let any teacher tell you, they'll tell you correctly, right? And of course, 2005 minus 1997. So this is where it gets kind of fun, guys. Even in the question, it says, round values to the nearest hundredths. So I got a slope of 9/8. I'm going to go ahead and get a b now, and the b comes from what we've already done, guys. We've already known to look at the y-axis right over there, right? Go up and down. Where does it cross the y-axis? Well, right there. The line goes, boop, hits the y-axis at 12. Now, I put the question mark because, of course, is it 1199? Is it 1150, right? I'm good with that. Y equals 9x plus 12. It looks good to me. It sounds good to me. But what about C? Predict the price of a ticket in 2009. Huh. Okay. I love this because a cake could be like $400. And then why is it wrong? It says predict. I predicted it. Why is it got to be a good prediction? You kind of get it, right? But all you guys want to do is go ahead and plug in 2009. Maybe? No, guys. Well, I'll say yes and no. Again, as you know, we've done a great job, guys. Not a long video, nice short one, but I'm going to leave it with you to kind of decide a better way. If I were to plug in 2009, would that work out for me to get a dollar value for the price of the ticket? Okay, I see where you're going with that. What about this? Could you kind of keep that line going? You know, that line of fit. And by having that line of fit keep going, you're gonna notice, it seems like every year it goes up how much? Well, you have a slope. You can rise and you can run. You go up and to the right, up and to the right, up and to the right, until you get a prediction that you feel good about, guys. Enjoyed this one, guys. Hope you got a laugh, hope you got a little knowledge, and I hope to see you back. B&B.